seeding NMF. What we can do when we perform non-negative matrix factorization is we can seed the algorithm in such a way that we're basically trying to tell the algorithm, here's some idea about what I think those things are. I'm going to tip you off, similar to k-means, right? I'm going to tip you off and say, I think the things are going to kind of be like this. So start from here and then do the rest of the algorithm and figure out what you discover. So there are these modes in the buff NMF algorithm called bases mode is the actual attribute or argument. And there are 3 different modes you can set. There is bases mode 0, which is the default. And what that does is the bases will be initialized randomly, and then the NMF process will unfold, and then you'll get what you get. And this is, again, one of these examples of an algorithm being initialized with randomization, and then performing iterations of optimization, and then giving us the result after all of that iteration has sort of come to a point of diminishing returns. There's another mode we can set, bases mode 1, which is the example that we'll look at in a moment here. And what we do with that is we actually seed the bases. So when we give it a buffer at bases, in that buffer will be some information saying, this is actually what I think you're going to be looking for. And then from those seeded bases, the algorithm will do its thing, do its optimization, and then give us the results. And hopefully our seed will help it find what we want it to find. There's another bases mode 2, that we're not going to look at. But what you would do with it is you would take bases and you would seed the algorithm with some bases. And you're actually saying to the algorithm, don't modify these bases at all. These are the spectral templates that you are looking to find. Don't modify the bases. But what it will do is it will modify the activations and therefore give you activation curves, these loudness curves through time, that it discovers based on these bases that you've given it. So bases mode 1, here's what I'm going to do. I'm going to tell NMF, I'm going to give it the drum loop, and I'm going to say, I'm going to seed these bases, bases mode 1, and my bases buffer contains this information. I've created these algorithmically, fill a buffer. If the frame is less than 10, then buffer value equals 1. If frame is above 10, buffer value equals 0. Just the sine curve from buffer start to buffer end is from 0 to pi of sine, right? So I've just filled these manually, but this is what I'll seed the NMF algorithm with. I'm going to say, I think the templates you're looking for are similar to this. Now, of course, what I'm hoping is that this will end up being the kick basis, this will end up being the snare basis, and this will end up being the cymbal basis. And if I seed buff NMF with this buffer of bases, tell it bases mode 1, and then run the algorithm, it will give me 100 times out of 100, which I can say because I've tested it, it will give me this as the result. It'll give me the kick in basis 1, the snare in basis 2, and the cymbal in basis 3. The reason I was testing this is because in order to create a lot of these visualizations, I had to run the same algorithm a bunch of times and render the picture and blah, blah, blah. And so I realized if I start with the bases initially randomized, sometimes I get the kick in basis 1, sometimes I get the kick in basis 2, sometimes I get the kick in basis 3. It would usually find the kick, but I couldn't control where it would be because that initial randomization will mean it could end up in any one of the 3. But if I seed the bases with these, with a buffer of these templates, then it will always return them to me in this order. And so that was what was really beneficial about that. And then my activations also will always be in that order, right? Because my bases are always in that order, my activations will always be in that order. And therefore also my components, my resynthesized individual components will always be in that order. So it's a really useful way of getting some control over that as well, which is nice. Another thing I could try is if I wanted to decompose a melody like this one, I might say, I want to get out all the different notes. And I happen to know that this is in C major. So what if I could seed my NMF algorithm in such a way that I could say to it, what we're going to be looking for are notes in the C major scale. The way that I did that was I started with a C major scale of sawtooth waves. There we go. So just sawtooth waves, C major scale, and I perform non-negative matrix factorization on this buffer. I'm not seeding anything yet. I'm just doing a normal buff NMF. Here's my buffer. And of course, I told it 8. I'm looking for 8 things in this buffer. And so it gives me these 8 bases. And sure enough, those look like the spectra of sawtooth waves. So it has found for me the 8 different components that are these 8 different timbral or spectral templates that are in that buffer. And here are the activation curves for each of those. So they're sort of in a mixed up order. But the first basis has the E, the second basis has the G, here's the low C, here's the high C, B, etc. Here are my different notes of the C major scale. So now if I take these bases and I seed my operation, my buff NMF algorithm with these bases, and then put in the melody as the buffer that I want to analyze, what I'm telling the buff NMF is start from these bases. I think that these spectral things will be in the buffer that we're going to analyze. And I want you to find for me where in that buffer these spectral things are. So this one is a spectral template, is a basis, and it is frequency against loudness. These are 8 spectrograms of the spectral templates that I'm seeding it with. These activations are time and loudness, or presence of each basis, the activation curve. If I take these bases and I seed NMF with these bases, my bases of the C major scale, and I do an NMF decomposition on the melody, I get this. And we can see that this is my low C. This is my C, da, 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 da. My melody there has the different notes extracted into these different components based on those bases analyses. Now you'll see that some of my activations here are pretty meager, because these are the notes of the C major scale that actually aren't in the melody Somewhere Over the Rainbow. And so I have some spectral templates, some bases that I seeded it with and asked NMF to look for, but aren't really present. And so those are very much lacking in their energy in the activation. This is a pretty common automatic transcription technique to use non-negative matrix factorization to extract components that have individual pitches separated out as separate components, because then the activations, you can tell, well, here's where there is some A, right? And it's very easy to convert something like this into MIDI notes, for example, using just a simple threshold here. So just like we can seed the bases, we can also seed the activations. And this is the same 3 settings as the bases mode. We can set the attribute act mode. The default is 0. The activations are initialized randomly, and the process will unfold from there. Act mode 1, the activations are seeded. So we get to point the algorithm in a particular direction, saying, here's where I think in time, because they're activations, here's where I think in time these different sound objects are that I want you to decompose. And then there's also an act mode 2, which would say, here are some activations that I am seeding, but do not modify them. Now, the bases in this case would be updated. So we would learn the spectral templates based on our seeded but not changed activations. Again, we're not going to talk about act mode 2, but we'll look at act mode 1. So if I were to go back to my sawtooth wave scale, which is 8 notes, they're all 1 second long, and seed the activations like this, when I decompose that scale, I'm telling NMF there will be one sound object at the beginning of the buffer, another sound object for the second second of the buffer, another sound object for the third second of the buffer, another sound object for the fourth second of the buffer, etc., up till the end of the buffer. And so I'm telling it where in time are these different sound objects that it should look for. So this is loudness. This is an activation curve. So it's loudness and then time. If I seed these activations and decompose that C major scale, I end up with the same bases that I had before. These sawtooth waves are now, these are the spectral templates. So this is frequency and loudness. However, I have it such that I have them in order that they occur in that C major scale. So I have C, D, E, F, G, A, B, C. So then, if I were to decompose the scale, now I have the resulting decomposition of the melody, but they are now they are in order. This is the low C, this is the high C, this is D, E, F, G, A, B, C. And so this is how you might want to go about it if you're doing automatic transcription, because now you can take these activation curves, convert them into MIDI notes or something using a threshold, and know for each activation curve which note of the scale it is. Whereas before, when we did this, we had them in a random order. Here's D, which does not exist in the melody, so we won't hear it. Here's E, which does not exist in the melody, so we won't hear it. Here's F, which does not exist in the melody, so we won't hear it. And now here's the G. So I'm using a FluCoMa object to do these graphs. I'm using fluid waveform in SuperClutter. And now here's the high C. You'll notice that the high C has a little bit of activation for the low C because, of course, the spectra of those two notes are going to be somewhat overlaid. The best way to do it, and the most common way of doing it, is using a buffer that you receive from buff NMF as your bases buffer. So if you use, or your activations buffer. So if you use a fluid.buff NMF, and you give it a buffer at bases, which is how we got the bases out when we did our analysis in order to be able to give the bases to NMF filter or NMF match. We could then use these bases in another fluid buff NMF operation by specifying the same thing. At bases is this buffer bases, but now we want to say bases mode is 1. And this is specifying that this bases buffer that I'm giving you contains the information that I want to seed the process with. This is now my seeded bases buffer. If bases mode is 0, which is the default, whatever's in this buffer, even if I have seeds in there, whatever's in the buffer will be erased and replaced with random values, and then buff NMF will do its thing because it'll seed the bases buffer with randomization. But this will say, don't randomize bases, just start from this template that I've given you and then do the process, do NMF. And it's the same with the activations. X mode 1, and activations can also be a buffer that was received from a previous buff NMF analysis.